Hello, and welcome to a new lab about yet another architecture. Today we'll talk about quite a peculiar one in the sense that it's not real-world architecture, in the sense that it's not implemented on hardware because it's a video game. It's called TIS-100 and it's developed by Zachtronics. Everything you need is available on the UV, but well, obviously, if you like the game, I encourage you to support them and buy it on GOG. Now, what is particular about this architecture? As we'll see together, it's composed of nodes communicating with each other and very limited in the available data and program memory. The aim of your assignment is to solve two custom levels, as you read in the handout. And to do so, you will need a documentation of the TIS-100. So let's take a quick look at it, but bear in mind that one of the aim of this session is for you to be able to develop some agility concerning the unknown. When confronted with a new architecture, a new language, a new piece of technology, how do you react? How do you organize your time efficiently to produce the desired result in a short matter of time? So, the documentation goes over some general aspects of the TIS-100 before detailing the architecture first and then the instruction set in details. We'll look into the former when we play around with the game a bit later. The instruction set is actually quite limited, but it's more than enough to handle your task. It's somewhat similar to the assembly code you wrote during the RISC labs, but it's not the same, and you can only use the instruction present in the TIS-100 documentation and none other. We can classify different kinds of instructions as follows. We have the instruction doing nothing. We have those moving data around for memory management, arithmetic operations, and then jumping around the code. Now, let's take a look at the game itself to better understand how to use them, and please refer to the handout in order to understand how to load the custom specifications, that is the exercises per se, and let's solve the first puzzle together. This is the first screen you will see upon launching TIS-100 for the first time. It prompts you to consult the manual, and if you did not already do so, well, we strongly encourage you to follow the console and to open the manual to help you solve the exercises. You have two main panels in the game. This one is the incorporated exercises inside the game, all the puzzles inside the game. Those are just to train you, but what is important for the assignment and for the lab is what is inside the second tab, the specification editor. When you click this button on top, it will open a new view into the game, and if you followed the instructions in the handout, you should have different custom specifications. The co-prime detector and decode the image are the two exercises you should solve for the assignment of this lab. Let's try to solve the first exercise together. So we select it and then create a new program, and you will see what different cycle count statistics, etc. mean when we finish the exercise. On the top left, you see what is expected to solve this puzzle. So we need to read value from in.x and write that value to out.x. In.x is the input at the very top left of the top node. And we need to forward the value coming from in.x towards out.x at the very bottom left of the node. The way it works is that inside the node you can write the instructions, and the one we need to solve this puzzle is simply the move instruction, taking value from up, coming outside of the node from upward, and pushing it downwards to the next node. We do the same, and we do the same again until we reach the output of this chain. The second part of the assignment here is to read a value from in.a and write a value to out.a. At the very top right, in that node, we need to move what comes from up and move it to the left. Then on the left node, we move what is coming from the right and push it downwards. And we keep going up until we reach the out.a node at the very bottom right of the screen. Those nodes in red are blockage in your path that you need to avoid. Now, on the left part, you see all the values you will have in in.x and in.a that will come from above the program, and then what is expected on out.x or .a to successfully pass the assignment. If we run it, we'll see that everything is going according to plan. We forward the values correctly, and at the end, we should see our statistics. We turn to the segment list, and now in the program we created, we can see that we reached the end in just 83 cycles, 8 nodes used, and 8 total instructions written. Those 3 statistics, the 3 metrics, will be essential for you to score a good mark on your 2 assignments for this lab.